host it could accommodate in each class A, B, and C. Today, we're going to talk about a few more details such as subnet mask, DHCP protocol, and DNS protocol. Okay. Priyanka is going to be joining today.
I think he is sleeping.
Okay, no worries, Priyanka. That's okay. Good.
I am trying to call, but
okay, no worries, Priyanka. That's okay, no problem. Right. So coming to the next topic, guys, is subnet mask. So again, if you open up your command prompt, so if you just search for cmd and go to your command prompt, and over here, if you type ipconfig, you can notice it shows you a private IP. We talked about it yesterday. How do you check your private IP? And under the private IP, you can see under the IPv4 address, you have two other pieces of information. You have something called subnet mask, and then there's something called default gateway. So let's talk about this today. What is subnet mask and what is default gateway? Okay. So when you talk about subnet mask, this is for the computer to understand which IP belongs to which class and how many devices can it connect to. Okay, so because you know in class C we can only connect a maximum of 255 devices. In class B we can connect a maximum of 255 into 255 devices, and in class A we can connect a maximum of 255 into 255 into 255 devices. So we humans can understand which IP belongs to which class from the network and host portion. We know class A contains one network portion and three host portions. Class B contains two network portions and two host portions. And class C contains three network portions and one host portion. But how does a computer understand which IP belongs to which class? Okay, and how does it differentiate these classes? So for the computer to understand, what it does is it differentiates it with the network and host portion as ones and zeros. So for every network portion, for every bit in the network portion, it assigns the value of 1. And for every host portion, it assigns the value of 0. So now in class A, where we have one network portion and three host portions, it assigns all ones in the first portion and all zeros in the remaining three portions. Okay. And now when we convert this from binary to decimal, you get the value 255000. And that is the subnet mask value for class A. So whenever you see a subnet mask like 255000 in the command prompt, it means that your IP belongs to a class A IP. When you see the subnet mask as 255.255.0.0, which denotes two network portions and two host portions, it means that belongs to class B. Oh, 1 second. Just a second, guys. Hi, Amir. Can you hear me? Hello? Hey, Amir. Can you hear me? Am I audible? Perfect.
Recording in progress.
Right. So as mentioned, now when you come to class C, guys, which has three network portions and one host portion, you have all ones in the first three portions and all zeros in the last portion. And when you convert that from binary to decimal, you get 255.255.255.0. Okay. Now if I check my command prompt here, remember in my command prompt, I was getting the IP 192.168.0.7, and this is a class C IP. And since it belongs to class C, you can see the subnet mask is 255.255.255.0, which is quite similar to what I have highlighted here. Okay, so again, from the subnet mask, you can also tell which IP belongs to which class. Is that clear, guys? Kumar, Priyanka, Victor. Victor, I guess this is your first class. You haven't joined the previous sessions. This might seem a bit confusing to you, but I hope you're familiar with any networking concepts beforehand. Victor, can you hear me? Okay, I guess Victor, your mic is unmuted, but I'm unable to hear you much. So, but yeah, Priyanka, any questions on your end? Kumar says all clear. Okay. Now, under subnet mask, you can see there's one more value called default gateway, guys. Now, this is actually your router's IP. So your router gets the name default gateway. It's just another fancy name given to your Wi-Fi router. The reason being, it acts as the gateway, the default device through which any device can send packet to the internet. So between your private network and the public network, your router acts as a gateway. So when any of your devices, your local devices, your phone, your laptop wants to communicate with the internet, they always have to send the packet to the router in between. And from the router, packet goes to the ISP or towards the internet. So the router is acting as a gateway there for your home network. Okay, hence the name default gateway. And it always gets the first IP in the network, 192.168.0.1. As you can see, the first IP is always assigned to the router. 0.0 is never assigned, guys. It's called the network ID. You never assign the network ID to any system. The usable IPs that you have are only from 0.1 to 254. Okay, and the first IP is always assigned to the default gateway or your router in your network. Now, coming to the next part is how do we assign the private IPs? So if you remember, I've told you public IP is assigned by the internet service provider. We do not have any control over the public IP. It is given to you by the ISP. But private IPs are in our control. Okay, if we want, we can change our system's private IP ourselves. So there are two methods that your system usually gets a private IP, guys. One, there's an automatic method, which means there's something called a DHCP server, which gives you an IP address. In our home network, our Wi-Fi router itself acts as the DHCP server. So our Wi-Fi router or the DHCP server are one and the same device. Okay, so the Wi-Fi router can provide the private IP automatically, or alternatively, we can manually give it ourselves as well. So if we want, we can modify the IP ourselves. So let me show you how you can change the private IP for your system manually, and then I'll explain how do you get it automatically as well from a DHCP server. So if you want to change your system's IP address, you can always go to your control panel. Oh, sorry, just a second. Quit. Yeah, so you can always search for control panel. And in control panel, if you want to change your IP address, you have to go to network and internet. And in network and internet, you have to click on network and sharing center. And in network and sharing center, you have to go to change adapter settings. So here you can see all the adapters for your system, your Wi-Fi adapter, your Ethernet adapter. Okay, so these are all the interfaces through which your device can communicate with other devices. Okay, so the adapter through which I am connected right now to my network is the wireless adapter, the Wi-Fi adapter. And you can see a green color signal bar here, which shows that this is connected at the moment. So which are not connected, you see a cross mark on them. Okay, so right now I'm connected through my Wi-Fi adapter, and the Wi-Fi adapter itself was giving me a private IP. If you remember, if I type IP config, you could see under my wireless adapter, Wi-Fi adapter, I was getting the IP 192.168.0.7. So in my system, there is a wireless chip, the wireless adapter chip, which is getting this IP from the Wi-Fi router. Now, if I want to change this, let's say from 192.168.0.7, if I wanted to change it to a different IP, like 0.100, how do we do that? So first step number one, you have to go to the Wi-Fi adapter setting, right click on that adapter and click on properties. Once you click on properties, you should get a pop-up as such, Wi-Fi adapter properties, and then you select IP protocol version 4 or internet protocol version 4, and you click on properties again. And when you click on properties, you can see there are two options. Option 1, you can get the IP automatically, or option 2, you can assign the IP manually yourself. So if you select the second option, now you can type the IP address of your choice. Okay, so if I type 192.168.0. let's say 100, if I want to assign that IP for my system, I can specify that IP. What should be the subnet mask for this, guys? This is a class C address. Remember, 192.168.0. This is always a class C address. So for class C, the subnet mask will be 255.255.255.0. Okay, and then you have to give the default gateway IP, which is 192.168.0.1. Okay, so in the olden times, guys, when you did not have DHCP servers, it was the job of the network administrator to assign an IP like this to every system in the network. So he would go to every device, and for every device, he would assign a unique IP this way. by going to the control panel, selecting the adapter, going to the properties, and then assigning an IP himself. Okay. So after these three important pieces of information are given, then you have to give something called a DNS server, right? So we have not talked about DNS servers yet. I will be explaining DNS servers in a minute, don't worry. But just in case, if you do not know what to be entered here, you can always go to your browser, and in the browser, you can search for Google DNS server IP. And when you search for that, you get two IP addresses. One is 8.8.8.8, and there's another one 8.8.4.4. And you can enter any one of them. Okay, what is this DNS server? I'm going to explain that in a minute. Don't worry, guys. I'll explain what it is very clearly. But for now, if you want to fill out this information, you can put 8.8.8.8 here. Or alternatively, you can also give 8.8.4.4. Primary, preferred, and alternate DNS. So again, first line contains the new IP address which we want to assign. Second line is the subnet mask telling this system which class it belongs to. Third line, default gateway, is the router's address. So if this device wants to communicate with the internet, it needs to know the router's IP. Okay, and then we have assigned the DNS IPs as well, 8.8.8.8 or 8.8.4.4. Where did we get this information from? For the DNS server, I went to my browser, just searched for Google DNS server IP. And this is constant, guys. It will never change. These are the common or the default DNS server IPs, 8.8.8.8 and 8.8.4.4. They're constant. They will never change as well. Okay. Once everything is configured properly, you can just click on OK, and that will change your system's IP. Now, since I'm changing my system's IP, guys, we might get disconnected from the meeting for a while. Don't worry, it will automatically reconnect back. Okay, so you might lose my audio, you might not see my screen for a few seconds. Don't panic, it's going to be fine. We will reconnect back. So when I click on OK, and when I click on OK, Amir, can you hear me? Kumar, Priyanka, Victor, can you hear me? Am I audible?
Yes, you're audible.
Right. And now if I go to my if I go to my command prompt, earlier, if you notice, my IP was 192.168.0.7. But if I type ipconfig again, this time my new IP is 192.168.0.100, as you can see, the IP which we assigned manually. Okay, so how did you assign it? By going to properties, IPv4 properties, and giving the IP manually here. Okay, so again, in a real time, we might not have the necessity to do this, guys, unless and until, let's say, our Wi-Fi router is not working, it is not able to assign an IP. We don't have to do all this troubleshooting. Okay, but just in case, if someone ever asks you, how do you change the system's IP? This is the procedure for it. Okay, now, as mentioned, in the olden times, when you were the network admin, it was your responsibility to go to every system and assign a unique IP like this. So for device 1, you will assign for router, you'll assign 0.1. For the next device, 0.2. For the next device, 0.3. For the next device, 0.4. Like that, you'll go on assigning every system a unique IP in your network. Okay. If it is a small network, it's pretty easy, guys. It won't take very long, like 10-15 devices, max to max 10-15 minutes or so, right? But if it's a larger network, let's say like an MNC company where you have 500 devices, you're going to every system and assigning an IP manually is a very hectic task, might take very long. So that is why they built something called a DHCP server, dynamic host configuration server. Okay, and just with one click of a button, so if I just select this button, obtain IP address automatically and obtain DNS server automatically, with just these two clicks of buttons, my system will automatically get an IP from the DHCP server. So if I click on OK again our connection will disconnect, guys, for a while. Don't worry. So now, if you notice, I've selected the first option, and if I type ipconfig again, you can see I got my original IP back, 192. 168.0.7, okay, from the DHCP server. Now, how is this happening? How is my device getting this IP from the DHCP server? And what is a DHCP server? What does it do? So the purpose of a DHCP server is given in its name itself. So DHCP stands for Dynamic Host Configuration Protocol. So what it means is it is used to dynamically or automatically configure an IP address, an internet protocol address, to every host in the network. So it is used to automatically assign an IP address to each and every host that is connected in the network. And this happens with something called a DORA process. So let me explain what this DORA process is. So again, let me show this with a diagram, please. So as mentioned, in your home network, your Wi-Fi router itself acts as a DHCP server. So let's assume this is my Wi-Fi router. Wi-Fi router, which is also acting as my DHCP server. Okay, and this DHCP server or Wi-Fi router gets the first IP in the network, 192.168.0.1. And now your DHCP server has a pool of free IPs. Okay, so now from the next IP, 192.168.0.2, to the last IP, 192.168.0.254, it has a list of all the free IPs in it. Okay, one second, guys. Someone's knocking at my door. Let me just quickly get that. So sorry for the interruption. Yeah, I'm back. So as mentioned, your DHCP server has a pool of free IPs. A pool in the sense it has a list of all the IPs that it can assign to every device which is connecting to it. So let's say if I bring two systems, if I bought two laptops, and if I connect it to the Wi-Fi router by entering the password, what happens is your router now. Okay, so if I have two devices here, device 1 and device 2. Okay, now if these two devices are connected to the Wi-Fi router by entering the password, your DHCP server or your router will assign each of these systems a free IP available. So the first system might get the IP 192.168.0.2. Second system might get 192.168.0.3, the next available IP. And whenever an IP is assigned like this, the IP is removed from the pool. So now the new pool will begin at 192.168.0.4, the next available IP. Okay, because it should not assign the same IP to another device. Okay, so every device needs to have a unique IP, right? So whenever an IP is assigned to a system, it is removed from the pool. Okay, and this is being assigned with something called DORA process. Oh, sorry, DORA. Now let's talk what this DORA is. So let me bring one more device in my network. So let me erase all of this. Okay, and let's say there's the pool beginning at 192.168.0.4. And now, oh, one second, guys. Someone is asking a question. Okay, yeah. So let's assume I brought one more system in my network over here. Okay, now this device, when it is connected with, when you enter the correct password for the Wi-Fi router, and when it is connecting with the Wi-Fi router, first thing this device does now is it starts sending a packet called the discover packet. So it sends a packet to every system in the network. Okay, and this packet is called the discover packet. What it means by this packet is it is asking every device, are you the DHCP server? Are you the DHCP server? Are you the DHCP server? So no matter how many devices are connected in the network, it asks each and every one of them, who is the DHCP server? I'm trying to find the DHCP server so that I can get a new IP. So when it reaches the wrong systems, they will just block that packet. So they just don't accept it at all. Okay, so they just cancel it. But when it reaches the correct system, okay, that device or that DHCP server responds back and it says, hi, you are looking for me and I am the DHCP server and I can offer you an IP address now. So for that discover packet, when it reaches the correct DHCP server, it offers an IP. Let's say 192.168.0.4. Okay, the 0.4 IP. Now, once that offer is made, your device says, hey, thanks for offering me that IP. I request you to allocate that IP to my system and remove it from your pool so that you don't assign it again to someone else. So that request is sent from the client. And for that request, your DHCP server again acknowledges it or confirms it. So it sends an acknowledgement in the end, which is like a confirmation telling, hi, I've got your request, I acknowledge it, and now I'm sending this IP to you. So this acknowledgement is sent, and with that acknowledgement, this device gets the 192.168.0.4 IP. And with that assigned here, it gets removed from the pool now. So now the new pool begins at next IP, 192.168.0.5 to assign to the next system. And this whole process of discover, offer, request, and acknowledgement is called the DORA process. D for discover, O for offer, R for request, and A for acknowledgement. So whenever you connect your phone to the Wi-Fi router by entering the correct password, your phone performs the DORA process with the Wi-Fi router. And with that, your phone gets a private IP. Similarly, when I selected that option, obtain an IP address automatically, my laptop performed the DORA process with the Wi-Fi router. And from that DORA process only, it got the IP 192.168.0.7 instantaneously. Okay, is that clear, guys? Any questions or doubts up to this point? Amir, Kumar, Priyanka, Victor, what the DORA process is and how the IP is being assigned. Victor, your mic is getting unmuted, but I'm unable to hear you. Are you trying to speak something? Okay. Priyanka, any questions? Amir, any questions? Yeah, Priyanka, did you say something? Again, your voice is also very low.
No, sir. No, sir.
Okay. Okay.
No question.
Right. Now, coming to the next protocol, we have something called the DNS protocol or a DNS server. Let's talk about that now. For that, Amir, any questions on your regarding the DHCP protocol? Okay, assuming no questions. Now let's talk about perfect. Right. Now coming to the next part is what is DNS server. Now, in order to explain about DNS server, I can explain this very simply with an example of your contact book application in your phone. So everyone has an Android phone or an iPhone right now. No one can survive without a smartphone in today's age. And one of the most important applications or one of the most important purposes of a phone is to dial up or to call other people. Okay. Other than that, your phone is being used a lot more for social media these days. But again, that's secondary. But your phones were actually built for you to contact or you to call up other people, right? And how does that happen, guys? Your phone has a SIM card which has a 10-digit contact number, and that 10-digit contact number calls up the target 10-digit contact number. So a connection is made between these two SIM cards which have their own unique 10-digit numbers, right? So if you want to contact a person, like let's say with this contact name, you dial up this number. You want to contact mom, this number, sister, this number, Shoaib, this number. So every person will have a unique 10-digit contact number to which you will dial up, okay, from your phone or from your 10-digit contact number, right? Now, when you dial up, you obviously cannot remember all the contact numbers because that might be a huge list, and humans can't remember such 10-digit long numbers for multiple contacts. Rarely, I can say we hardly remember 10 or 15 contacts, not more than that, right? So remembering all 100 or 150 contacts in our phone or more might be a very quite impossible task. So what we do is we save a name for each contact number, and next time when we want to search, we search by that name as well, right? So when you want to call up Shoaib, you search SHOAIB and then you dial up that number. And from that, your phone understands, okay, I have to contact this 10-digit number to dial up the number of Shoaib. So your SIM card has no relation with what you save this name as. You can save it as Shoaib or you can save it as cybersec trainer. Okay, cybersec trainer, or whatever it be. It is not concerned with what you save the name as. Your SIM card is only concerned with what its 10-digit SIM card number is and what the target 10-digit SIM card number is, right? Similarly, your browsers also work in a quite a same fashion. So when you go to your browser, and in the browser, when you search here for www.google.com, your browser actually doesn't understand this language. It doesn't know, or it doesn't understand what this www.google.com means. It doesn't understand those alphabets. Your browser actually needs this google.com website's public IP. So this website google.com is being hosted somewhere on the internet on a physical web server. And that web server, which is hosting google.com, has a public IP to it. So your browser needs that public IP to connect to the target website, okay? Because all traffic on the internet flows with public IPs. So from your public IP, which is being given to your router needs to send the packet to the target public IP, which is hosting google.com. But how does that router know, okay, where is that public IP? So in between, there is a server called a DNS server. Usually these DNS servers are maintained by your ISP, Internet Service Provider. So when you search for google.com, this request now goes to a DNS server with your ISP. Okay. So again, let me draw this out. So if let's assume this is your system here. Okay. If this is your device, and in your device, if you're searching for google.com in your browser, this request first comes to a router. So in your home, you might have a router. So from that device, from your computer, the packet goes to the router. From the router, the packet goes to the ISP, Internet Service Provider, right? And your ISP now has its own DNS servers. Okay, so again, it has its own server, a DNS server. And in this DNS server, it has something called host records. What I mean by host records is it has website names, let's say google.com, and to that website name, it links its exact public IP, 1, 2, 3, 4, for example. The next website, bing.com, it hosts or gives the relation for that website, 2, 3, 4, 5, the public IP. youtube.com, okay, and for youtube.com, it gives its exact public IP, 4, 5, 6, 7, something. Okay, yahoo.com. So basically a DNS server contains the linking between every domain and its exact public IP. So yahoo.com might be on 5, 6, 7, 8. Okay. Now, so when you're searching for google.com, that packet first comes to the router. From the router, it goes to Google, to the ISP. From the ISP, it goes to a DNS server. And from the DNS server, it gets to know, okay, so the user is searching for google.com. So I need to send the packet to this IP, 1, 2, 3, 4. And from the DNS server, now the packet goes to that target server where you have Google's physical server hosted on that public IP, 1, 2, 3, 4, 1.2.3.4 for the website Google. Okay, so this is how your packets travel over the internet, guys. When you search in the browser for google.com, your browser actually doesn't understand that language. It needs to know the public IP. So for it to know the public IP, it needs to obtain that from a DNS server. So the packet goes to your router. From the router, it goes to ISP. From ISP, it goes to a DNS server. From the DNS server, it gets the public IP. And from that, it goes to that exact public IP, 1, 2, 3, 4. Okay, so the main job of a DNS server is to link every domain name to its exact public IP. Just like how your contacts application is linking every contact name to its 10-digit contact number, your DNS server links every domain name to its public IP. Okay, so if I show you an example for this, I can clear all this drawing. And if I go to my terminal or my command prompt, and in my command prompt, if I run a command called ping, P-I-N-G, ping is a command to check for connectivity. So when you run ping, your device starts sending some packets to the target website or the target IP. So if I give ping www.google.com, what happens here now is my system starts sending packets to Google's server. And from Google server, it gets a response as well. As you can see, ping statistics, it says sent 4 packets, received 4 packets from that target and lost 0 packets, which means there is proper communication. There is no loss of data anywhere. Okay. Now, and if you notice here, when I'm pinging to google.com, I'm getting a reply from an IP 142.250.77.132. If I copy that IP, if I go to my browser and if I paste that IP here, and if I hit enter for 142.250.77.132, you can notice it is loading Google website. So this was the actual IP for google.com. But since we humans don't have to remember it because of a DNS server, we are giving the domain name. So when you enter google.com, or even when you enter the IP, it still reaches the correct server, all thanks to the DNS server, because the DNS server is linking this domain name with this exact public IP. If you did not have the DNS server, you have to remember the public IP for each website. Okay, and that would be a very hectic task. Okay, searching for that again, exact that contact number, dialing that contact number, very tough. So that's why to easily search for it, we remember the domain names: google.com, yahoo.com, so and so. Is that clear, guys? Any questions? Priyanka, Victor, Kumar, Amir. I hope it is clear what a DNS server does. Again, easy to remember. DNS server links every website with its exact public IP. Okay. Any questions? Priyanka? Kumar, oh, Kumar said no, no questions. Amir, Priyanka, any questions? Okay, perfect. Yeah, Victor, I just saw your message. So there probably might be some issue with your microphone. No worries. If there's anything, you can text me in the chat box. So any questions, Victor? Okay, assuming there are no questions, let's go into the next topic. So if you remember now, coming back to this, when I entered Google DNS server IP, so if you notice when the computer was asking enter DNS server IP, I entered these IPs. So these are the IPs for DNS servers maintained by Google. So the Google, which is your search engine, okay, which has its own DNS servers, publicly available DNS servers, which anyone can use. And in these DNS servers, there's linking or there's records for every website on the internet. Okay, so that's why when it asked for DNS servers, I gave these addresses. Okay, if you don't give this address, your system will automatically get the DNS server from the ISP, Internet Service Provider. If you don't know what the ISP's DNS servers are, you can always give these addresses, okay, instead. So this is what I meant by a DNS server. Okay. Now proceeding to the next topic, or the last topic for today's class, is special IPs. So in your whole IPv4 range, guys, there are two special IPs as well, called a PIPA and loopback. So again, these are neither private IPs nor public IPs. Okay, so again, there's one more category called special IPs, and they have their own special purpose, mostly for troubleshooting. So let me explain each of them. When you talk about loopback IP, loopback ranges from the number 127.0.0.0 to 127.255.255.255. So any IP within this range is called loopback IP, guys. Okay. Why is it called loopback? I'll explain in a bit. Don't worry. Okay. But the purpose of a loopback IP is to check if your NIC card is functioning properly or not. Now, what is this NIC card? So if you go to your browser and if you search for what is a NIC card, you can see this, you get some images. So this is basically what an NIC card looks like. Okay, and this NIC, which stands for Network Interface Chipset or Network Interface Controller, is the main card responsible for all your network connections. So this card contains all the adapters. It has the Wi-Fi adapter, the Bluetooth adapter, the Ethernet adapter. So whatever network communication adapters are required, all those adapters are placed on this one single chip. So you could say this chip is the main component responsible for all communications on your system. And if this chipset fails, your device will not get an IP address. It will not be able to communicate with any other system. Okay, so this is the main component on your device which is responsible for retrieving an IP and for communicating with other systems, because this contains all the interfaces, the Wi-Fi, Ethernet, Bluetooth, whatever. Okay, And if you want to check out if this interface is working properly or not, if your NIC card is functioning properly or not, you can run a command called ping again. So you can just ping to your loopback IP, PING and 127.0.0.1. You can either ping the first IP or you can also ping the last IP and any IP in that range, and you'll still get the same response if everything is fine. So you can see send 4 packets, receive 4 packets, lost 0 packets, which means everything is fine. Similarly, you can ping the last IP as with 127.255.255.254, and you still get the same response, which means this whole network of 127 is assigned to the loopback itself. So if you were to ask me, that was a huge wastage of IPs, frankly speaking. But back then they thought you have 4.3 billion IPs, so giving the whole 127 network is no loss. Okay, but again, that's a huge drawback. And the reason why it is called loopback, guys, is because if you notice, you're trying to ping to your own system. You're trying to ping to the chip on your own device. You're looping the connection back to your system. Hence the name loopback. Okay, so it's like you're saying hi to yourself in a mirror. Okay, and your mirror, again, in your reflection, you see yourself telling hi to you back. So you're looping the communication there. Hence the name loopback. Okay. Secondly, there's something called a PIPA. Okay. A PIPA stands for Automatic Private IP Assignment, and this ranges from the number 169.254.0.0 to 169.254.255.255. Okay, this is the PIPA IP range, and this IP is a special IP which is assigned to your system in a rare case scenario, and the scenario is where your device is not able to retrieve an IP both from manual and automatic methods. What I mean by that is, usually your system can get a private IP in 2 ways, either automatic from a DHCP server or manually where you are assigning it yourself. In a scenario where your DHCP server is not functioning and neither are you assigning a private IP yourself, in such a scenario, the operating system, the Windows operating system or the Linux operating system, will assign a private IP itself. And that private IP is called a PIPA IP, 169.254.0.0 to 169.254.255.255. Okay, so in this control panel, or sorry, in your command prompt, if you type ipconfig, right now I'm getting the IP from my DHCP server 192.168.0.7. But if my DHCP server malfunctions for some reason, or if it doesn't provide me a private IP, in this location I'll be getting an PIPA IP, which means I have to understand or I have to troubleshoot what is wrong with my DHCP server. Okay, so that is what a PIPA means, guys. Okay, a PIPA as well, an automatic private IP is assigned to your system by the OS when both manual and automatic methods don't assign an IP. Okay, and loopback is your, again, as mentioned, the IP for your NIC card. To check if your NIC card is working properly or not, you can ping on the loopback IP. So these are the few concepts required, which will again be enough for us to get started with cybersecurity, guys. There's a few more topics, which is IPv6 address and CIDR, but I'm going to talk about these in upcoming classes. Okay, so I'll explain these in the upcoming sessions. But for now, these are more than sufficient to learn about networking. So again, a quick recap. What all did we learn in networking? We talked about IPv4 addresses. We talked about the properties of IPv4 addresses. We talked about the binary numbers and binary to decimal conversion. From that conversion, we got the first IP and the last IP. From the first and last IP, we understood the range of IP addresses. Okay, and from the range, we understood the categories: class A, B, C, D, and E. And in each class, I gave you the ranges for private IPs and public IPs as well. And after we understood this, then we talked about subnet mask, default gateway, DHCP protocol, DNS protocol, and special IPs. So this is what we have learned in the last 3 sessions, including today's. Okay, so this is more than sufficient, guys, to get started with networking. In tomorrow's class, we're going to go into the practical part, where I will be showing you how to install your practical lab setup, a tool called VMware, which is a virtualization software. And inside the VMware, how do you install this operating system called Kali Linux? So you can go to this website called kali.org. This is the official website for downloading this operating system. So this is a Linux-based operating system, guys, and one of the most important, one of the most advanced pen testing operating system. So this is one of the most popular operating systems which contains all the tools required for hacking or ethical hacking. And in tomorrow's class, I'm going to show you how do you install Kali Linux on your devices. Okay, so it's completely open source and free. Anyone can download this for free to learn or use all the tools required for security training or security testing. Okay, so yeah, that's that for today's class, guys. Nothing further for our session today. I'm going to exit the class now. And
So
yeah, Kumar.
can we install this into external hard disk?
No, Kumar, you might not be able to do that because, as mentioned, it might be running a bit slow on your external hard drive. So it needs to fetch the tool from there, from the external drive, your internal system memory. So that is going to hang your system a bit. So recommendable that it is recommended that you run this in your base machine itself and in the physical storage of your base machine rather than in an external drive. You can run it, but it will be slow. It will hang a lot. So that's the only problem. Kumar, is that you?
Yeah.
Right, guys. So yeah, that's that for today's session. Nothing further, guys. I'm going to exit the class now, and I'll see you tomorrow at the same time. Bye-bye. Good night.